Thank you very much, Angelica. I will speak in Italian, thanks to my interpreters. Well, I'm going to talk to you about the Regional Biodiversity Observatory of Lombardy. And I have decided to call it repository and not archive because the idea is to try and go beyond what Sonke was talking about before. So trying to match all the pieces of the jigsaw. Of course, this pattern can be improved, and we need to use all the data coming from different sources and that are collected from different sources. So it's a multi-purpose repository. And of course, if data can be archived and used in a very correct way, well, as Angelica said, the results can be very positive, and they come from different sources. So just to give you an idea, I'm going to talk about the fauna in Lombardy. We've got 246 sites, Nature 2000, that covers 50% of regional area. And we also have more or less 200 species in Directive Lombardy and more or less 170 fauna species. The problem is that anthropogenic pressure causes huge stress on these species. In Lombardy, we've got quite a lot of problems, and not only in the mountains, but also on a low land. Of course, it can cause some different problems on segregated populations. So, I don't know, invasions, climate change, genetic bottlenecks. So when numbers start decreasing, of course, the biodiversity will decrease. And of course, what can it entail? Well, increased extinctions and of course, that problem was tried to be dealt thanks to Gestire 2020. And a second risk, an increased risk of global extinction. As you can easily imagine, monitoring becomes more and more essential. We need to understand where species are distributed, their conditions, and what we can do and what interventions we can take in order to be active in a proper way. Moreover, we need to collect these data and analyze them. So let's talk about the Observatory of Lombardy. Initially, it was considered as a tool for describing the conservation status of DH species and to update standard forms. Number two, to collect, sorry, now it has become something different. It has gained more power. So, for example, it collects and integrates all data relating to wildlife monitoring. It evaluates the distribution of species and also the trend of conservation status and threats. So we try to do something more starting from the repository of data that was collected in the past. Moreover, it tries to be a tool to make data available, data that has already been analyzed and simplified, and make distribution data available to the public. Public produces data analysis for the managing bodies of protected areas. Last year, even the ministry started to allocate some funds to monitor species, and these funds in the Lombardy region are given throughout the Regional Biodiversity Observatory of Lombardy. And moreover, as I was saying before, it makes distribution data available to the public, but it makes some data analysis available for the managing bodies of protected areas. Where does data come from? Well, of course, the data sources, first of all, we've got some experts. Then I'm going to give you some examples where if we do not have experts, we can't find a good solution and have good results. Well, for example, we've got ARPA that studies water management. Another source, well, projects. But sometimes we get some leopard stain data. So we study some parts of Lombardy. So we know some things about species, and we know where it is distributed, but maybe we do not know anything about other places of our region or state in case we want to keep on studying it. So if we do not have data, it doesn't mean that that species does not exist there. And then we've got some data sets from research centers and museums, wildlife recovery centers. Many data coming about bats actually comes from wildlife recovery centers. Then we've got the territorial network, because Sonke talked about it. We've got many different associations. Here I have, you know that there are many more associations, so what Sonke called Network 2. Then we've got Network 1, so technical staff of parks, and then also some groups of volunteers with specific trainings. And then we've got citizen science. Well, we've got registration on the observatory site. Everyone can subscribe. So anyone can ask to subscribe. Then, of course, that person got the Biodiversity app. And then we've got online databases, massive databases or social databases. For example, the most famous, if you want, iNaturalist, that we deal with thanks to some records inside the observatory. What I would like to highlight in that phase is that actually there is not a difference about these three groups. So in general, experts are work also in the territorial network. For example, experts that are experts on dragonflies maybe do work on ARPA or other associations or the wildlife research group. And there isn't also a very clear distinction between the territorial network and the citizen science group. For example, our experts, but even also myself, I study fish and marine organisms. Well, we are present on the app, on the database iNaturalist. And of course, as you can see, everything is more or less intertwined. This is the number of accumulated records in the observatory database. Of course, bird life is the main field. Birds are a sort of flag species that attract that monitoring, and we've got so much data because many different databases have been merged, and now we've got all this quantity of data. We deal with iNaturalist in a different way, separately, because we have implemented a project where people can, if they decide to enroll, tell us the right coordinates of protected species. It is possible to download data from iNaturalist, but if we do that, the coordinates of protected species are altered. Why? Well, in order to avoid poaching. So we want to use data in a different way, data coming from iNaturalist, and then little by little we will try to understand how to make these, how to let these data enter the database. There are more or less a 6,000 quantity of data inside the database, and then it will add also 200,000 in the iNaturalist website. So here you can find the coordination points coming from iNaturalist. If let's have a look at the eye density. You can see that there are some places that are darker. So your urban and semi-urban areas. Because of course I can report much more because these places, areas are more populated. Then we've got the most accessible parks and natural areas. So everyone goes near Ticino and take pictures of dragonflies. Here we've got some tourist areas. The Garda Bresciano is a protected area. And if we zoom in, we see that all the airports are along the lake. And then we've got some flag areas, the Stelvio National Park. If we did an analysis, we would find almost every time the same species there. So how to harmonize data and how to go beyond a simple distribution map based on present reports. If you want to make an elaboration to go towards a direction Sonke quoted before, of course, we also need to deal with this huge amount of data, because of course, data coming from iNaturalist is, for example, the geographical point, and more or less that's it, and the species. But for the observatory database, we have actually created some columns of metadata where we can put inside some data that can be used for those who want to analyze it. Here, for example, we have some data about fish in general, fish fauna, fish life, and we can analyze data taking into account a group. And of course, we can choose just things we need and to analyze what has been sourced. Then we've got also some data about some environmental variabilities on about the area that has been monitored. If you want, we can try to understand, if you want to understand the relationship between the population and the environment, we also need to take data coming from different sources. Another interesting thing is, for example, that we need to put some record, looked for but not found, searched but not found. Sometimes it's not always taken for granted, because that's fundamental. We populate maps with some expert work focusing on some areas. And on these maps, we can find many different points of presence reports, and there are some areas that are completely empty. And we don't know if these areas are empty because there is no monitoring, there are no monitoring activities, or there are no animals. So let's talk about crayfish, freshwater crayfish. It is only expert monitored, life projects, and, for example, academic research for different reasons. We need to have some data that we need to collect, and not simply just monitoring it by chance. And we need to understand the rise or decline of population. For example, we have studied 100, we have seen 100 crayfish on a small part of the river, but it's not enough. We also need to study different other things. And moreover, we need to avoid harm to populations. If a person wants to take a pictures of crayfish and the day before, without knowing it, where there are some alien crayfish, let's say, and have, for example, the crayfish malaria, that is actually a disease that could kill a lot of crayfish. And maybe without knowing it, goes there and might kill the left populations. Thanks to the accident monitoring, here you can find the sites on the pre-alpine place where the crayfish is now living, because in the lowland, alien crayfish occupied more or less all the territory, so they had to move. And if we take into account the decline of the increase of this population, we can see that the green part is where the crayfish is, its population is raising up. In red, maybe there is no population. We've seen some problems in different sites, and we have also understood why they are caused. And we also try to use these animal. It's something that we do within the framework of Gestire 2020, and we also found new populations that have not been put inside the map, but the new violet square will be put inside. Let's talk about the red swamp crayfish. So citizen science can be very complementary to the expert monitoring. If you've seen that the crayfish can be monitored by experts, well, whereas the red swamp crayfish, we need to change things. I don't know, I have seen a crayfish. I can take a picture, I can upload it on the iNaturalist, and it will help us to understand whether these species is expanding or not, and especially how and where. This is an alien species, do not forget. And then it's also possible to have a sort of early warning. We have already seen on iNaturalist pictures of crayfish where they do not generally stay there.
This is just an example. We can identify critical areas where there can be an overlapping, even in specific parts where we need to be more careful. All the interventions of eradications of the red swamp crayfish we talked about this morning happened where you see the yellow squares. So there is a higher alert, while in other places, these squares do not overlap. because there is a difference of space between the presence of the red swamp crayfish and other populations, our populations. Another short example, an example of easy processing is the black woodpecker. We saw earlier that we were talking about the forest species of birds which are increasing. The black woodkeeper is a perfect example, and we can see it through data of the observatory. In 2010, the distribution of the woodkeeper was this, so just some in the Alps. A few years later, it increased, and in 2022, not only did it increase, but we also seen many nucleuses in the lowland. Is there also a citizen bias? That means that the last few years, reports increased greatly due to web sharing and mobile phones. Maybe it was wider than we thought, but no one had a mobile phone to take pictures and post them on the internet. How do we know that it's true? Because as far as birds are concerned, we have data sets, as we've seen before, that increase the amount of data we have that go back in time. So from that database that collected people on the territory, we know that even if this is a little underestimated, so the previous absence in the lowland, the increase of the black woodkeeper is not underestimated, so we know that it's a specific species in the forest due to the abandonment of specific reasons. We know that is doing much well. This is my last example related to the climate change. So database can be useful for this too. The violet darter is not an invasive alien species. It's not expanding, but it is just expanding because there is a better habitat. It likes more in Italy. So in this map, as you can see, before 1930, there were two reports in Italy. It's a Middle East species, basically, so very hot weather. 70 years later, it was seen here and there. And during the last year, starting from 2000, there was an increase in the appearances in Lombardy, thanks to the database of the Regional Observatory of Biodiversity. From 2018, these three, which are the one in red, circled in red in our distribution map, in just 5 years more, see how it increased. So from the first parts in the in some parts of Lombardy, like Milan, Brescia, and other parks, spread by reaching the Iseo Lake and other areas along the Po River. And that's a symptom, we could say, of how climate change is acting. So to conclude, a centralized data repository allows you to take advantage of monitoring coming from very different sources and make them much more easily available. And it allows to manage them in a better way because we can manage all metadata as well. So not all fields we've seen have to be filled, but every time there is available information, we put it. We can manage them. While the local regional scale allows for greater efficiency in administration of data, so we all know people that give us data apart from citizen science, so we have a constant dialogue on how data have to be collected. This, at the same time, can limit the possibility of cross-border exchange because we all have our repository, and then there is another difficulty when we're able to agree on that, we will have to do something with that. We don't know if we collected, for example, the same metadata. Anyway, the metadata increase the possibility of harmonization and intercollaboration among collected data. They allow filtering, and they also allow more complex processing and analysis, even though there are limits. I've already said that before. For example, we were not able to register metadata about community structure or functions, so complex species are collected one by one and kept one by one, and then we have to do something to talk with the community. There are there's no much data about the environment, so the complex relationships among species and communities must be recreated from raw data we stored. And just once more, this is very important in my opinion, and we should put this possibility in niche database, so the possibility to put the search but not found, because it allows us to create true distribution maps, even though we don't know whether we have to look for territories where the species was not searched. The experience of the repository tells us that expert and professional monitoring cannot be replaced, especially for certain species and environments. Full stop. That's clear, because at the political level, it looks like citizen science is the origin of all evil, but we've seen that's not true. But citizen science can be a good complement. First of all, to survey broad areas, for example, against invasive species, alien species, to understand distributions, as we've seen in the case of some species, and to point out reports that need to be further investigated. Territorial network, according to us, in our opinion, proved to be the most powerful tool to acquire big and accurate data sets. He put together and gathers the expert. So it's a good complement to the fact that he's paid to do detailed things, and at the same time produces very accurate data sets. So it has probably the greatest cost-effectiveness ratio. And it is also a pool of available experts or when we need it, and also a source of training for citizens, then can produce better data. So, in our opinion, the use of all potential sources, even when or if can create problems, allows for the best allocation of limited funds.